Hello guys, my name is Shanushka Tomar. Today in this video, I am going to discuss about neural network in data science. Here in this video, what we will see how to demonstrate application of neural network using Python. Now, let's get started. Here, first we will understand what is neural network. So here, neural network is a type of machine learning model that uses artificial neuron to process the data in such a way that mimics the human brain. There are a wide range of application of neural network, such as image recognition, in speech recognition, natural language processing. Here, neural network are also known as artificial neural network. So now, here let's read this. Neural network are computational models inspired by human brain which is used to recognize pattern and solve problems such as classification, regression, and image recognition. There are also many applications like speech recognition or natural language processing. Below, we will demonstrate a simple neural network for classification using Python's Keras library, which is a part of TensorFlow. Now here we will use the Iris dataset to train the neural network. This dataset is a common dataset in machine learning, which is used to classify flower based on their features. For example, sepal length, sepal weight, petal length, petal width. Now let's see the code of how to demonstrate how to demonstrate application of neural network by using Python. This is the code for the application of neural network using Python. Here we have imported some necessary library which is NumPy. NumPy is used to create array for the input X and target Y data. Here we have also imported TensorFlow.keras model and TensorFlow.keras layer. Here we have imported sequential and dense. So here TensorFlow Keras dot model, a Keras class which is for building a sequential layer by layer neural network. And here, this is a fully connected dense layer of neuron. Here we have generated a sample data by using np.array. Here in this, we have taken a dataset X, which is taking input dataset with 4 examples, each having 2 features, and Y, which is a label for the XOR problem, that is a classic binary classification. Now we will define the neural network model. Here we have written model is equal to sequential. Under bracket we have written dense for input dimension to activation value or dense one activation sigmoid. So here sequential create a linear stack of layers and dense defines a fully connected layer. So this is a hidden layer with 4 neurons and output layer with neuron. Here the first layer 4 neurons. Input dimension 2 specify the input size 2 features per sample. Here activation value applies the value activation function for non-linearity. And in second layer, that is output layer with neuron 1 for binary classification, here activation sigmoid output a value between 0 and 1 probability. Here now we have compiling the model. Compile the model. Model dot compile. Here we have written optimizer is equal to Adam loss is equal to binary cross entropy and matrix that we have used is accuracy. They are optimized Adam optimizer. It is an optimizer that adjusts weight during training. And this binary cross entropy, which is used for loss function for binary classification task, and the metrics we have used is accuracy that tracks accuracy during training. Now we will train the model by using model.fit. Here we have written dataset xy epochs 100 verbose 1. Now what is it? Here fit, what is fit doing? Here fit train the model on the input x and target y. Epochs 100 run the training process for 100 iteration. And what is the use of verbose here? It display training progress. Now we will make the prediction. So here we have written prediction is equal to model dot predict. Under we have written x. Here predict use the train model to generate prediction on the input data. The output is probability of for each sample. Now here what we have did in this, we have made an input layer. In input layer, first layer takes the input feature x which in this case are two values per example, and a hidden layer which contain four neurons, each processing the input using the ReLU activation function. This helps the network capture non-linear pattern. Here in the there is output layer which has one neuron with a sigmoid activation function which gives the population for binary classification. Now let's see the output of our code. Wait, output is getting loaded. This is our output of here. What's the output? The prediction 0.4, 0.47, 0.621, 0.4781. Each prediction is close to 0 or 1, which is indicating the model has learned the XOR function. Here in this code, we have seen the prediction is closer to 0 and 1. That means which is indicating the model has learned XOR function. So that's it for today's video. Thank you for watching my video. Now see you in the next video.